Now let's consider current implementation of our technology. Our current platform is a web platform, so it's oriented to creating of structured websites for different purposes and different subject domains. Just right now we are discussing an example which is devoted to the Euclidean geometry. It is intelligent reference system, which is implemented as a local website. Here you can see the hypertext variant of our external language. You can just follow different links as usual and read some information about subject domain. For example, about subject domain of Euclidean geometry. But the main point is that these pages are not defined previously. They are created dynamically from our semantic network. As I said before, we have graph representation too. We can easily switch from hypertext representation to graph representation, and here we see the same information. So, stored knowledge is not dependent from representation language. From our technology we provide two universal forms of external representation: graph form and hypertext form. But we can create different specialized interface components, for example, for the Euclidean geometry, that will be an editor for geometry drawings. Now some words about our interface. As you see, all the text is written in Russian language, but we can easily switch to English language or any other language represented in our system. We have such an opportunity because our representation allows to separate identifiers in each language, for example, Russian language, English language, and so on, and elements which correspond to these identifiers. So we can only change identifiers without changing data itself. Let's continue with English. All you see on that page has its representation in our semantic memory. That means that we can ask question to any element of the interface, and even every. That means that we can ask any question to any element you can see on that web page. To ask any question, we use quite simple algorithm. We press that green button to switch into argument selection mode. For example, we want to know for what purposes is that field used. So we select it as an argument and ask a very simple question. We call that question request of full semantic neighborhood. In natural language it can be said what is something. So system can tell us about any element of user interface or any element of system as whole. Here we can see a small video how to use that search field and other useful information about that component. That means that system can explain its own interface by itself, and user shouldn't read any special books to learn how to operate with that system. You should only know one simple algorithm. Press a button, select a component, and select the question which you want to ask. And now let's try to solve geometry problem. Our system has several simple examples. Let's consider one of them. There is a circle with length 18.84, and there is a square which side is the radius of that circle. The question is, what is an area of the ABCD square? Let's switch into English and ask a question using well-known algorithm. The argument will be area of square, and the question will be find value. So the area is 9. We can ask system how this answer was calculated. For that we can use special command to search solution steps. And system said that first of all it used formula of circle length calculating for circle AB, and the next step was using formula of square area calculating for square ABCD. So these two steps were enough to solve given problem. Due to our unified approach to knowledge processing, we can even integrate different problem solution methods in one system at one time. And due to unified representation of knowledge, system can even explain how the problem was solved. Thank you for your attention. We will be glad to answer all your questions. Goodbye.